In these slides, we want to apply the equation of motion for the charged particle in the magnetic field and to find the radius of the circle that it will move on. So we know the force on the charged particle is QV cross B. The magnitude of the force is the magnitude of the charge times the magnitude of V cross B. What's the magnitude of the cross product between any two vectors? It's the magnitude of the first, magnitude of the second, times sine of the angle between them. Now the V is this way, and the magnetic field is into the page, indicated by the crosses. So the angle is 90 degrees. So sine 90 is just 1. So you just have that the magnetic field is just QVB. So that's the force acting, that's the magnitude of the force. Now the force is perpendicular to the velocity vector. It's pointing towards the center of the circle. And so we can apply Newton's law for the radial motion. Newton's law for the radial motion says that the sum of the forces in the radial direction is equal to the mass times the radial acceleration. So the sum of the forces in the radial direction is just QV times B. And the mass as it is, and then the acceleration of any particle moving in a circle is V squared over R. Remember, the speed doesn't change. The speed stays constant. Because of the change in the direction, the acceleration, the radial acceleration, is V squared over R. This you've taken in mechanics. When you have an object moving in a circular path, the radial acceleration is V squared over R. You combine those two things, this will be the equation of motion for the charged particle. The force is the mass times the acceleration. And because you have V here and V here, you can simplify things and you can find the radius as mv over qb. So this will be the radius of the circle that the charged particle will move on.